Well, hello everyone and welcome to another problem solving session on Special Maths Academy. And in today's video, we are going to cover one problem from the Senior Maths Olympiad first round 2020, problem 4. And the question is a functional equation problem, and it goes like this. Let f be a function that maps natural numbers to natural numbers, and it satisfies this property f of x, which is like sometimes also written as f of brackets, x is equals x plus 2, where x is a member of natural numbers. Which of the following properties is not necessarily true? So these are the options. As usual, I can try and test out of the option. But first of all, it's just a good idea to just explore this equation and see what we can get first now. Not that I'll just go around and start randomly testing options. So let's start write the equation out. So functional equation is mostly about manipulation. So we can replace x with f of x. And we can do that because we are safe to do this because f of x is still a member of natural numbers. If it were to be like another domain, maybe real numbers, we may not it may not always be safe to do that. But because it's n to n, as it's called, we are safe to replace x with f of x, and it will still be a member of the domain. So replace x with f of x, and we get f of x. That is 3 f's. It's equals f of x plus 2. So let's call this equation 1. Then what other way can we try to get this f of 3x? F iterated 3 times to x. We can also get this by applying f to both sides of the equation. So when we apply f to both sides of the equation, what do we get? Get f of x equals f of x plus 2. So this is also the same thing on this. So because these two are the same, then this right hand side are also meant to coincide. So it implies that f of x plus 2 equals f of x plus 2 for all x member of n. So this equation is much more easier to work with than what we are given. But actually, we see this equation we got here is a property of this original function, but we're just working with this property first of all. It's a very strong property though. So from here, we can even get that the first option is actually a property. So the first option is not the answer. As you can see, also just working with this equation, even without looking at the options, we just helped us already get an option is not it's a property, so it's not the correct answer to this question. So then from here now, okay. So let's try and put x equals to 1 now. Okay, then first of all, let's put x equals 1. So when x equals 1, what do we get? We get f of 3 is equals to f of 1 plus 2. So let's put x equals to 2. F of 4 is equals to f of 2 plus 2. So now, let's put x equals to 3 now. I just want us to be able to see something. So when x equals to 3, we get this equals f of 3 plus 2, which is an f of 3 has been found before. But remember, f of 1 and f of 2, we don't know the previous value. That's why we didn't resubstitute anything. But f of 3 has been found to be f of 1 plus 2. So this is f of 1 plus 4. Then also when we put x equals to 4, we get f of 2 plus 2. F of 2 has found, sorry, f of 4 plus 2. F of 4 has been found before to be equals f of 2 plus 2. So this will be f of 2 plus 4. So as you can see, us following this pattern, we can be able to find f of every number greater than 2 in terms of f of 1 or f of 2 plus some other constants. So that, those ideas, this property we noticed, it helps us to be able to it leads us to naturally say to define f of 1 and f of 2. So now we can be let f of 1 equals a for some unknown constants a, and f of 2 equals to b. Then definitely a and b should be members of natural numbers because that is the range of the function. So we can just replace this with a. So f of 1 is equals to a. Let me write f of 1 is equals to a. I can clean this out now. I believe we all remember the property. Let me write it above here. F of x plus 2. So f of 1 is equals to a, f of 2 is equals to b, f of 3 is a plus 2, f of 4 is b plus 2, f of 5 is b plus a plus 4, and I'll just clean that, a plus 4, and this is b plus 4. Then if we have not yet seen out the pattern, we can keep on going until you see the pattern. So f of 7 is what? F of 5 plus 2. So what is f of 5? A plus 4. So that is a plus 6. F of 8 is equals to what? F of 6 plus 2. What's f of 6? We have found it before. B plus 4, that B plus 6. So definitely, I believe from now, like a lot of us can even notice the patterns. And patterns like this on natural numbers can easily be proved by mathematical induction. So I'll skip the proof in this solution, but it can be done easily with mathematical induction. So first of all, see that f of 1 is A, then f of 2 is B, f of 3 is A plus 2, B plus 2, A plus 4, B plus 4, A plus 6, B plus 6. So we're expecting next one to be what? A plus 8, B plus 8, A plus 10, B plus 10, and all that. So you notice that the numbers that have A attached to them are 1, 3, 5, 7. Then 9 is expected to have A attached to it. So like all these numbers, 1, 3, 5, 7, 9, they are all odd numbers. It's not so difficult to notice that. And the ones that have B attached to them are all even numbers. So by observation, we can be able to like observe that f of an odd number will have A plus, because the odd numbers have A, then what is the constant term that will be added to the odd number? Okay, let's check it out now. So this constant term here is, since no constant term is written, it can be assumed that constant term is 0. So this is 0 and the number is 1. When the number is 3, we're adding 2. So that is 1 less than 3. 0 is 1 less than 1. When number is 5, we're adding 4. When number is 7, we're adding 6. So we're expecting that when number is something, we're adding that number minus 1, odd number minus 1. So this is not like very, very rigorous way of writing. The rigorous way of writing an odd number is like 2k minus 1. So we can like say that f of 2k minus 1 is equals to A plus 2k minus 2 for all k member of natural numbers. So this is for all odd numbers. 2k minus 1 represents all odd numbers from k equals to 1, 2, 3, 4 till whatever infinity. So for all k covers what I just wrote now. Then for the even numbers, it's very similar. First of all, f of even. We saw earlier on that all the even numbers seem to have B attached to them first of all. Then the constant term that is added is like here, since no constant term is added, we can assume it's 0. Guys, it's 0, no, we can assume it's 0. Yeah, then for 4, it's 2 that is added to it. So 4 minus 2 is 2. 2 minus 0 is also 2. For 6, we add 4, that is 2 less than the number inside the bracket. For 8, we add 6, that is 2 less than this number. So it's not so difficult to guess that even number will be this, the even number minus 2. So to write it properly, even numbers can be written in this form. A plus 2k minus 2 for all k member of n. So as I said, it's not so difficult to use mathematical induction to like show that this is actually the solution. So the solution to this equation, now let me write it here now. Solution f of 2k minus 1. This is representing all the odd numbers. And this is representing all the even numbers. Like there's no way to like do them together at the same time because of the way this because the gap here is 2. If the gap were like 1, yeah, it's just consecutive. There'll be no need to make 2 fixed constants. But if the gap here were to be 3, it's not so difficult to see like they could have been, like the first 3 numbers could have been made constant and all the others could be able to be found in terms of the first 3. So this number here is crucial. So that's why there are 2 constants that are unknown and cannot be further simplified. So f of 2k is A plus, B plus 2k minus 2 for all k member of integers. It's positive integers, natural numbers, they are the same thing. So I can clean out all this. I believe we all understand the idea behind it. Everything can be proven by math induction. It's not so difficult to see that. So I'll clean out all these things now. We have gotten f of our values. So we just have to like, now that I've found f of the values, we can directly test out the properties and see which is true or not. So now, yeah, we have shown that property A is a true property. So like, it's not the answer to the question. So now this property C and D now. Okay, let's look at it again. Property C says f of 1 is even. Remember, f of 1 is the same thing as A here. So it's saying A is even. So now let's check if it's true or not. Suppose A is A is odd. If you want to like check if this is true. Okay, now the reason why I didn't want to test property, the second property is because like I'm trying to like the reason why I didn't want to test second property is because it's not a very, very wide property. It's just like saying that this is the only function. Like there are a lot of all the other properties in this question are more general than this second property. This second property is just like verify. It's a solution to this, but we can't like be so sure that this is not the only solution. So that's why I want to like test all these other general properties first of all. If I go to this last one, it's very, very specific. That's why I omitted it for now. Because it's giving us the exact function. No other property here gives us the exact function that f is equals to. So yeah, so now to the third property says f of 1 is even. So we want to remember we're trying to look for the answer that's wrong. So now let's suppose otherwise. Suppose f of 1, which is what? A is odd. Now suppose A is odd. So what are we going to do now? Remember, I said as we got this thing, remember, we use this fact to get all this here. And if you remember what I said this is a very strong property of the original question, but it doesn't have everything the original question has. So like we still have to go back to the original question and do some things. So suppose A is odd, let's come back. Remember, this is our question. Now just look carefully here. He's here that things get a bit tricky. So if A is odd now, when we put x equals A, what do we get? We get that f of A is equals to what? A plus 2. So now, if A is odd, which of the functions are we going to use? We are going to use the one for odd, the one for the odd numbers. That is this first one. If A were to be odd. So what will it translate to? Remember, this number here is just A plus 1 minus the number here. So f of A will translate to what? It translates to f of A plus. It translates to f of A plus 1 minus the number here. That's A minus 1. That is yeah. It's the original question, right? Okay. That's A minus 1, yeah. So this f of this A plus 2. This A plus 2, yeah. So that's f of 2A minus 1 is equals to A plus 2. Okay, let's look at this again. Well, we replace x with A. So when I put x equals A here, how that is A plus A minus 1. This is the one for the odd numbers. So this is what we have. Yeah. So now, what do we do now? This is also under odd number now. So we now also use this first equation. When we use the first equation, what do we get? Get A plus 2A minus 2. That is the value of this using this first equation, because we just like it's going to be equals A plus 1 minus number inside here. This 1 minus number inside here is equals A plus 2. So what do we have here? We have 3A minus 2 is equals to A plus 2. What do we have here? Grab that 2A is equals to 4. So what does it imply? It implies that A is equals to 2. So we get that A is equals to 2 even. But what did we say? We are like assuming that A was odd. So this is actually a contradiction. We assume that A was odd and what that A was equals to 2. So they are contradicting each other. These two things, like they don't go well. They are saying opposite things. So it means that it means that our assumption was wrong. So actually the f of 1 is even. Like remember, it doesn't mean we have gotten an answer. It means that what was in the option is correct because we assumed otherwise. So this is correct. And suppose B is odd. It's very, very similar. So I'll just rush it through now because it's very similar to what we did. So it means option C is a correct property. So it's not a wrong property as the question is asking us to find. So suppose B is the option D now asks us to like find to say that f of 2 is odd. So we want to like show otherwise. So we want to like say suppose f of 2 is even. So f of 2 is what? B. So suppose B is even. You get the contradiction. It means that the option in the question is actually a property, it's a necessary property. So it's not the answer to the question. So suppose B is even, we put x equals to B. Very, very similar. Then because B is even, we use the part for the even values of the function. Like this one. So when x equals to B, what do we have? f of B will now be what? It should be B plus the number inside here. That will be B minus 2. Minus 2 is equals to B plus 2. So this is f of 2b minus 2 equals to b plus 2. So this is also under even number. So we use the even part of the function again. So what does this give us? It gives us that the number inside here is going to be equals to b plus twice the number inside. Sorry, 2 subtracted from number inside. That will be 2b minus 4 equals to b plus 2. So what does it give us? 3b minus 4 is equals to b plus 2. So calculating like terms, get 2b is equals to 6. So b is equals to 3. So 3 is an odd number. Well, like since that b is a what? Is even. So this is also a contradiction. So it means that this property is correct. So I believe we're all following. Okay. So now we have gotten that 3 properties are true. It's remaining this B and E. So as I said earlier, we still like go and check if E is true or wrong because it's a more general property than B. B is very specific. B is not even really a property. It's like finding the exact function. So we don't really test it. So now like check this option E now. Option E now. So they say we should try and show that this is true or false. So the way we're going to go about this now is we are going to okay. This is our original function now. We are going to plug in okay, so for this last property now, it's a bit tricky. So what we are going to put now is we are going to like in this our original equation, we are going to put x equals to 1. 1 put x equals to 1, what do we get? We'll get f of 1 is equals to 1 plus 2, that is 3. The f of 1 is a. So you get that f of a is equals to what? 3. Then remember, we have shown that f of a is even. So like we have shown that a is even, sorry, not f of a is even. F of a is odd here. So we have shown that a is even because like this third property, remember we did it, a is even. So now to find f of a, we have to use the even part of the function definition. That is this one. So what is now going to be is like f of a is now going to be equals to b plus a, b plus the number inside minus 2. So this is equals to 3. So we'll get that a plus b is equals to 5. So now from here now, remember a and b are they are both positive real number, positive integers, and a plus b is equals to 5. So can we conclude f of 1 is a is less than equals 4? So I definitely a plus b greater than equals a plus 1 because b is at least 1. It's a positive number, positive whole number. So it means that 5 is greater than a plus 1. So it means that 4 is greater than equals a. That's f of 1. Yeah, so this is how we do the fifth property, sorry, and the fifth property is also true. So this property is also true, and we have shown that all the other 4 properties are true. So the answer generally should be the last property that we haven't shown is true or not. So just for the reference sake, I'll find under we can like choose any value of a that is even between 1 and 4, and any value of b that is odd between 1 and 4, or any value of a that is even between 1 and 4, and use this equation to find the value of b, and we actually get a solution. that's not necessarily this. Okay, let me just give you a concrete example. Actually, this is almost concrete, but we can just like say let A be equals to 4 and B be equals to 1. So if we have this, this is a solution that is not this. So I found a counter example to this. Actually, if we did this earlier on, we could have gotten that this property is not necessarily true, and would have been done with the question, just that there may have been no intuition to like as why we broke this function like this. So that's why I decided to show the properties out. So this is how to go around with this question, and the answer to this question is option B. So this is a counter example, and that's how we conclude the question. So that's all for today, and I'll see you in the next video.